All right, hey guys. So we're combining functions again today. And in this one, we are just multiplying. The last lesson was about addition and subtraction. This one is about multiplying. So the only kind of past information that you need to try to remember here is when we're dealing with exponents. Now, just remember, if we're multiplying exponents that have similar bases, like this x and this x here, we just add the exponents together. So if I have x to the second and x to the third power, that's 2 and that's 3, which gives us 5. So remember, when we multiply exponents, we add them. So just like before, we have two functions. We have f of x equals 3x plus 4, and we have g of x is equal to x squared plus 2x plus 4. And we're going to multiply these two functions together. Now there's two different ways to go about this. There's kind of the longer way that to me makes a little bit more sense in my head, but this is honestly just the way that I learned it when I was a kid. The more modern method is a little bit neater. It's a little bit easier to organize. This is that area method that we talked about at the beginning of the year. Whichever one works for you, do it. I'll probably show this one a little bit more, but I will show how to do the area method with these examples. So, it's just whatever way works for you. This way is a little bit more about distributing. I'm not a big fan about drawing and making a grid and everything, but if we were to compare these, this is a little bit more concise. So it all depends on the question. So let me show the area method first, and then I'll go through the distribution method. So we have x squared plus 2x plus 4 multiplied by 3x plus 4. So we have one function here and another right here. And then it's just like a multiplication table. So 3x times x squared gives me 3x squared. 3x and 2x get me to 6x squared. Remember, x to the first gives me x to the second. 3x and 4 give me 12x. 3 times 4 is 12, and that x just goes there. Then we move down to this level. 4 times x squared gives me 4x squared. 4 times 2x gives me 8x, and 4 times 4 gives me 16. From here, I have 6 different terms, and I'm going to look for like terms. So we can combine them if they have similar exponents, if they have similar bases and exponents. So 3x cubed, to the power of 3. There's no other exponent of 3, so that's just going to stay the same. We have two x squares, 4x squared and 6x squared. And that, when we combine them together, it's going to give us 10x squared. Because we're just adding these, okay? The exponent doesn't change, the number in front, the coefficient does. We have 8x and 12x, which give us 20x, and then the 16 is all by itself here. So that is a pretty quick and concise method to do that. One thing that you probably saw me do a lot all throughout the year was to distribute. So basically, you take the first term right here, and we multiply it to each term in the second function, which is this guy here. We would then take the second term, this 4, and distribute it to each term. So I color-coded it here, 3x times x squared, 3x times 2x, and 3x times 4. That's what's happening here. Then we take this 4 and multiply it to each term here. I kind of ran out of room, sorry. From here, we get a bunch of numbers here. We're going to multiply them to get 3x squared, 6x squared, 12x, 4x squared, and 8x, and 16. So it's the same thing we did here. It's just a little bit longer. So then from there, we see that this and this is a like term, as well as 12x and 8x, which combine to get the same answer. So guys, that's the basics of it. If we're working with real life scenarios, word problems, everybody's favorite. So this one says that at a fall festival, the senior class sponsors hay rides. to raise money. The ticket price is $5, and each hayride carries an average of 15 people. They consider raising the ticket price in order to earn more money. So for each 50-cent increase in price, an average of 2 fewer seats will be sold. So basically that's saying if they increase a ticket by 50 cents, 2 less people will buy a ticket than if it was regular price. It also says, let the variable x represent the number of 50-cent increases. So this x right here and that x is the number of increases. The first part here is asking, write a function to represent the cost of one ticket based on the number of increases. So a ticket costs $5, $5, and we're adding 50 cents to each increase. $5, the initial cost, and then 50 cents per increase. That's what that means right here. This one wants to know a function r of x to represent the number of riders based on the number of increases. So this is kind of saying, this is more focusing on the number of people that are going to go on the ride. So if we start with 15 people at regular price, but then when we increase the price by 50 cents, 2 fewer seats are filled, it's going to look like 15, which is our starting value, and it's subtracting 2 people per increase. So put that all together, we basically are just going to multiply them together. 5 plus 50 cents times x multiplied by 15 minus 2x. Because I was running out of room here, I just decided to do the distribution method instead of the area method. So I'm taking the 5 and distributing it over here. I'm taking the 50 cent, the 0.50x, and distributing it again there. I color coded it here, and I got 75 minus 2.5x minus x squared. So that is the revenue function for the hayride that could be used to maximize revenue. So this combines both of these factors up here. Almost done, guys. Only 2 more examples. All right, so this is another simple one. It's just a math problem, no word problems or anything. So with this guy, we have f of x and g of x. We have 2x squared plus 5x minus 1, and we have 6 minus 7x. So we have a trinomial multiplied by a binomial. So I showed 2 methods here. We have the area method, we have distribution method. Now, here we have a trinomial. So we're going to take this 2x squared and distribute it to both of these terms. We're then going to take the 5x and distribute it. And then we're going to take this -1 and distribute that as well. So you're having to do it 3 times. When you get that, you get 12x squared, because 2x squared times 6 gives me 12x squared. We have 2x squared times -7x. A negative and a positive makes it negative. So that's 14x to the 3rd power. 2 and 1, right? Makes 3. Then we move on to the 5x, going to each one here. 5x times 6 gives me 30x. 5x times -7x gives me -35x squared. X and x squared. Then we move on to the -1. -1 times 6 is -6. -1 times -7x. Negative and a negative makes it positive. And then the x just kind of tags along there. From there, I find my like terms. Again, the exponent has to be the same as well as the base. So x squared, x squared. This number and this number are going to combine. Nothing can combine with this. And then we have an x and an x, so these guys as well. That -6 just drops down. So we get the answer of -14x to the 3rd minus 23x squared plus 37x minus 6. Showing it in the area method, same setup. We have the 2x squared plus 5x minus 1. Now keep that in mind. You don't really put the plus sign. You could, just if you want to, but it doesn't really serve a purpose other than signifying that this 5x is positive. We put a negative here because it's a subtraction of 1. So it's a negative 1, right? So we would go through here. 6 times 2x squared gives me this right here, and just keep going. All right there. There, we look for our like terms. X squared and x squared, we're going to add those two together. X and x, we're going to add those two together. And we get the exact same thing. So one more example, guys. This one's another word problem. It says that a local group is selling t-shirts to raise funds. They plan to sell 2,500 t-shirts for 10 bucks. They consider raising the t-shirt price in order to earn more profit. So kind of similar to the last word problem. So to increase their profits, they want to just make the t-shirts a little bit more expensive at $1. It says for each $1 increase, they will sell 100 fewer shirts. So when they increase the price, the number of shirts they sell goes down by 100. They might make more money if they sell enough, but less people are buying them. X represents a number of $1 increases, and we're talking about cost, and we're talking about the increases of t-shirts. So here we have cost, and here we have number of increases. Thankfully, it gives us the functions already. The cost is 10 plus X because it's $10. And then 2,500 minus 100X shows that they are trying to sell 2,500 shirts, and for each increase, they're subtracting 100 shirts sold. So we have our two. We're going to multiply them together, just like we've done this whole lesson. 10 plus X times 2,500 minus 100X. Again, I kind of ran out of room, so I just distributed. So 10 times 2,500 is 25,000. You just add a 0 on there. 10 times negative 100X is negative 1,000X. Again, just add a 0 onto that. Then we move on to the X right here. X times 2,500 is 2,500X, and X times negative 100X gives us negative 100X squared. X and X makes X squared. From there, my like terms are these two right here. This and this just drop down. So the revenue function, or R of X, in regards to all of this information up here, where t-shirts are $10, but we're increasing it by $1 each time. This is what we would use to try to maximize your profit. All right, if you're going to be like a small business owner, trying to sell stuff, anything, you will want to maximize your profits, but sometimes if you raise your prices, it might not be worth it. If your prices are low enough, more people will come, and it might actually create more profit. Sometimes if you don't have, a large population that's coming into your shop, let's say, you might need to increase the price to get more profit per sale. But that's a whole other tangent. So that's it, guys. This is lesson 2. There's one more lesson after this, and then we'll do a review, and then we'll do a test. And there's only like a month left of school, which is really crazy. So let me know if you guys have any questions. Make sure you're working on those tests. Progress reports are coming in soon. And if you hadn't completed that, any of the past tests at all, I haven't put in the grades for the last one yet, but I put in 0s, guys. So please, please, please get that done. And if you do, let me know and I'll change your grade. Thanks.